we're doing with matrices then today. We'll spend the day reviewing tomorrow, which I know you got some review with that. And then we'll take a test on Thursday, and then after the test, and then Friday and Monday and Tuesday you'll have review time for the exam. So, and I'll be giving you, tomorrow I will give you a packet or not a packet, but just a handout that tells you what lessons are covered in the exam, and then then there'll be practice problems for you to do, which actually you will be turning in to me on exam day. So it'll actually count towards the your homework for this marking period. So, all right. So today we're going to do matrix inverses and solving systems. And most of this is going to be focused, we're going to be using our calculator almost entirely for what we'll be doing with this. So that part of it will be easier for you. But we're looking at solving systems of equations still, kind of like what we did the other day, but it'll be a little different approach to it. We're going to be working with multiplicative inverse matrix, which is just a matrix that we really didn't look at it the other day, but it showed it the other day, that it's a matrix where you have zeros everywhere except for the diagonal, from the upper left to the bottom right. So the identity matrix, all right, looks like this if it's a 2 by 2, looks like this if it's a 3 by 3. Right? So just diagonals. Right? So the first thing we're going to look at is just determining whether two matrices are inverses. And to determine whether they're inverses, we're just going to multiply them and see if they produce, if it's 2 by 2s, then they should produce this identity matrix. If it's 3 by 3s, then they should produce that one there. All right. So determining whether two given matrices are inverses, we're going to multiply them together. And then look for the identity matrix. We're going to multiply them and look for the identity matrix. If we get the identity matrix, then they're inverses of each other. If we don't, then they are not. All right. And we'll talk more about inverses in a moment. So basically, when we're talking about identities, all right, or inverse, I should say, with an inverse is a reminder that an inverse of adding is subtracting. So if I had the inverse of positive 5, it would be negative 5. When we're talking about multiplicative inverses, those are reciprocals. So the reciprocal, if I multiply 5 and 1/5 together, I get 1. Okay? So when we're talking about just multiplying with inverses, then it's just multiplying by its reciprocal, because when I do that, I'm just going to get the number 1. So when we do it with actual matrices, we're looking for that identity matrix where we have 1s in the columns. All right, so go ahead and we'll go ahead and use 4 matrices, and we'll do them all at one time. All right, so we'll put this one in matrix A, this one matrix B, and then we'll use C and D. So go ahead and put those 4 in your matrices right now on your calculator. Okay, so to check to see if they're matrices, we're going to multiply them together. All right, so we'll multiply these two together for A. So on mine, those are A and B. So I choose matrix A. There we go. All right, had to go to the home screen. Okay. All right, here we go. So matrix A times matrix B. And we get on the diagonals just 1s. So these are inverses. Now we could do this by hand too. But much easier to do it this way. So if I multiply those two together for letter A. All right. So this is the identity matrix, so these are inverses. All right. So let's see for letter B then. All right, so I multiply them together. So in my calculator, those is C and D. So matrix C times matrix D. Right, and what happened? Oh, really? All right, so I made a mistake. Hold on. Okay, so when I multiply C and D together, then we get this matrix here. Since it's not ones on the diagonal, so then we can say that these two matrices for B, they are not inverses. All right, because we don't get that identity matrix. All right, so for A, we did get the identity matrix where we get just ones on the diagonals. For B, we do not just get the ones on the diagonals, so those are not inverses. All right, so that's the easiest way to check to see if they're inverses. Multiply them and see if you get just ones. Everything else should go to zero. All right. Okay. So the inverse of a 2 by 2 matrix is, so if we have a matrix A, B, C, D, then to get A inverse, what we do is we would do 1 divided by, now, you don't have to write this down, okay? Because we're going to do it with our calculator. All right? 1 divided by the determinant times, and notice that they change things around, all right? They switch the diagonal, A and D, and B and C to make them negative, all right? So all we're going to do is we're going to do it with our calculator, all right? So if the determinant is 0, it's undefined. And a reminder, for the determinant, we multiply diagonally and subtract, all right? So a matrix with a determinant of 0 has no inverse. It's called a singular matrix. Right? So we want to find the inverse of these 2 by 2 matrices. All right, so let's go back into your calculator then. And we're just going to use our calculator to do these. All right? And I'll show you how to do it with your calculator. So we'll put 4, 3, 2, 1 in matrix A. So go over to edit, 2 by 2, and 4, 3, 2, and 1. All right, so we'll quit. Let's go back to your home screen first. All right, so let's find, so we're going to just do the inverse of it. And the inverse is very easy. Okay. Bring your matrix up. All right, so we have matrix A. And then the button that we use for matrices, okay, the inverse button is right there. Okay, to -1 and hit enter. Right. Right. And so here is our inverse of that matrix. And so if I multiplied matrix A by its inverse, all right, so then I will get the identity matrix. All right, so you multiply matrix times its inverse, you get the identity matrix. So here's a way to check it to make sure that it's correct, is that once I find the inverse, I can multiply the matrix times its inverse in this order, okay? So always got to be A and then A inverse, and you should get the identity matrix, all right? So here's our inverse. All right, and here is our check to make sure it's correct. All right. And so when we did the check, we did matrix A times the inverse of matrix A. All right. All right, so go ahead and do letter, well, let's do B together, all right? So put that one in the matrices. And try to find the inverse of that. All right, so we were able to get our answer, make it into a fraction, check our answer, all right, and we can see that this matrix does have an inverse, and that is the inverse there. So here's our inverse. And here we checked it. Right. So do number 2 here then, on this check it out. Do that one. Okay, so there's finding the inverse of a 2 by 2. You can use the inverse of a matrix to solve systems of equations. This process is similar to solving equations such as 5x equals 20 by multiplying each side by 1/5 the multiple inverse of 5. So instead of with matrices, you can't divide, right? But you can multiply by the inverse, where, like we said here, this instead of dividing by 5 with 5x equals 20, the same thing is multiplying by 1/5. With a matrices, they do not allow you to divide, so we have to multiply. So to solve a system of equations with the inverse, you first write the matrix equation, right? AX equals B, where matrix A is the coefficient matrix, matrix B is just using your variables, or matrix X, excuse me, is the variables, and matrix B is your answers then. Right? So we have a coefficient matrix A, variable matrix X, and constant matrix B. And to solve them, we multiply A inverse times B, and it has to be in that order because matrix A, it has to be A inverse times B, right? Because matrix A is a 2 by 2, and matrix B is a 2 by 1, right? And if we did it the other way, if we did B times A inverse, we'd have a 2 by 1 multiplied by a 2 by 2, right? And that doesn't work because these numbers are not the same, right? So when you multiply them, you have to do it A inverse times B to find the value of X. So this is doing the same thing we did with Kramer's rule, right? Except it's actually a little bit easier, a little bit quicker, because you don't have to know the determinant in this situation. Right? So reminder that to do these, they have to be in standard form. So x plus y equals a constant, x plus y equals a constant. Right? So we're going to set it up. So here's your system of equations that we're going to solve. 2x plus 5y equals 0. 5x minus 3y equals 31. So we're finding where these two lines intersect. And so we need to know matrix A, matrix X, and matrix B. So our coefficient matrix, which is matrix A, 2, 5, 5, negative 3. The coefficient matrix is x and y. And our constant matrix, our matrix B, then is just going to be the answers over here, 0 and 31. So here's A, here's X, here's B. And to find X, we do A inverse times B. So we'll make matrix A in our calculator, 2, 5, 5, negative 3. And we'll make matrix B will be the matrix where it's 0 and 31. All right, so we have a 2 by 2, 2, 5, 5, negative 3. All right, and then matrix B is going to be a 2 by 1. All right, and that's 0 and 31 goes there. All right, and so back to our home screen. So we're going to do matrix, we'll take matrix A and inverse and times that by matrix B. Okay. And so we get this matrix here, 5, negative 2. Which means that we have the point 5, negative 2 is our solution. So we've actually learned on Thursday and today 2 different ways to solve systems of equations using matrices, which are really much easier and faster than doing substitution or elimination. Now, with substitution, or when you do them, they've got to be in the form of x plus y equals a constant, right? So, and then once again, with all of our checking, we could go back and check these, right? 2 times 5 plus 5 times negative 2 is 0, okay? 10 minus 10 is 0, that's true. Right? 5 times 5 is 25, negative 3 times negative 2 is positive 6, 25 plus 6 is 31, right? So it works. It's a reminder that what this does is it finds the intersection point of those 2 lines. Okay? And we could, if we had systems of equations with 3 variables, so x, y, and z, we could use this same format to do them. It would do those for us also with our calculator. Okay? So, looking to see if 2 matrices are inverses. If they are, then they must produce the identity matrix, right, where we just have 1s on the diagonals and 0s everywhere else. Right. To find the inverse, put in our calculator and use the inverse key. Right. And then if we're solving a system of equations, we multiply A inverse times B. All right. And here's your assignment.